Welcome to the next session on Module 5, that is Conductometry. Conductometry is an instrumental technique which is used to determine the amount of substance present in a solution by measuring the conductance. It is based on the theory that all electrolytes they conduct electricity by the migration of ions under the influence of an electric field. So conductivity of a solution, it is a measure of the ability of the solution to conduct electric current. Ohm's law states that current flowing through a conductor, that is represented by I, is directly proportional to the applied potential E and inversely proportional to the resistance R of the conductor. So conductance, it is the reciprocal of resistance. So C is equal to 1 by R. Conductance is the reciprocal of resistance. So resistance is equal to S into L by A, where S is the specific resistance and L is length of the conductor and A is area of cross section of the conductor. So substituting this value in this equation, C is equal to 1 by R, you will get C is equal to A divided by S into L, where A is area of cross section of the conductor and L is the length of the conductor, and 1 by S, it is the specific conductance. Now unit of conductance in SI units, it is per ohm or mho or Siemens. Now different types of conductance. There are three different types of conductance. Specific conductance, it is denoted by K, it is also called kappa. Equivalent conductance denoted by lambda, and molar conductance denoted by lambda m. So specific conductance, it is defined as the conductance of a solution which is placed between two electrodes of area 1 centimeter square and at 1 centimeter distance apart. Whereas equivalent conductance, it is defined as the conductance of all ions produced by 1 gram equivalent of an electrolyte in a solution. Whereas molar conductance, it is defined as the conductance of all the ions produced by 1 gram mole of an electrolyte in a given solution. Now factors influencing conductance. First is mobility of ions. If the ions are highly mobile or if they are moving fastly, then obviously the conductance increases. Whereas if the ions are very slow, the conductance will be less. Then number of ions or concentration. If the number of ions in the solution is more, then obviously conductance will be more. Whereas if the number of ions is less, the concentration will be less and hence conductance will be low. Now nature of ions. If the ions are bulky, then the movement of the ions will be less and hence conductance also will be less. Instead, if the ions are small in size, they will be moving fast and hence the conductance also will increase. So these are the three factors on which conductance depends on. Now instrumentation. A conductometer, it makes use of electrode, and this electrode, it consists of two platinum electrodes. Conductometer make use of a conductivity cell, and in the conductivity cell, two platinum electrodes are present, and these two platinum electrodes, they have an area of 1 centimeter square and they are kept at a distance of 1 centimeter apart. And these electrodes, they are dipped in a electrolyte solution taken in a beaker, and it is connected to a conductometer. Titrant, it is added from the burette, and the solution, it is stirred after each addition using this stirrer. Now conductance is measured after addition of titrant at intervals of 0.5 ml. So this is the instrumentation part. Now we'll come to conductometric titrations. So first we'll see strong acid versus strong base. Here a strong acid like hydrochloric acid, it is titrated against a strong base like sodium hydroxide. Now hydrochloric acid, it will be taken in the beaker, and sodium hydroxide, it will be taken in the burette. Initially, the conductance of the hydrochloric acid, it will be high because of the presence of fast moving H plus ions. So initially, if you note the conductance, it will be high. Now, after adding NaOH, what happens is that the fast moving H plus ions will be replaced by slow moving Na plus ions. As a result, the conductance decreases, and this will continue till all the H plus ions of HCl has been replaced by sodium ions to form sodium chloride. Now, after all the H plus ions of HCl has been replaced by sodium ions to form sodium chloride, after that addition of NaOH, it will result in increase in the conductance because of the presence of fast moving OH minus ions. So, this is the nature of the graph that you obtain when a strong acid is titrated against a strong base. And these two lines, they can be extrapolated, and the intersection, the point of intersection between these two lines will give you the end point of the titration. And this volume, it indicates the volume of NaOH that is required to neutralize the hydrochloric acid present in the solution provided to you. And using the formula normality of HCl, it can be calculated, because normality of NaOH, it will be known to us. Volume of NaOH we will get from the graph, and volume of HCl, it is the amount of HCl that has been taken in the beaker or in the sample cell that has been provided to you. So, with this you can calculate the normality of HCl. If the normality of HCl is known, amount can be calculated using the formula normality into equivalent weight of HCl. Now next is weak acid versus strong base. Here a weak acid such as acetic acid is taken. So acetic acid, it will be taken in the beaker, and the conductivity cell, it will be dipped in it. Now NaOH, it will be added from the burette. Now initially the conductance, it is found to be low because acetic acid, it is a weak acid, so it is only feebly dissociated. That means the number of H plus ions released, it will be less. Therefore, the conductance will be less. Now, upon adding sodium hydroxide, the H plus ions will be replaced by sodium to form sodium acetate. This salt formed, it is completely ionized, and hence the conductance, it is found to increase slightly. This will continue till all the H plus ions in acetic acid has been replaced by sodium to form sodium acetate. So, a slight increase in conductance is observed. Now, at this point, all the CH3COOH, all the H plus ions of acetic acid, it has been replaced by sodium to form sodium acetate. So, after that, the conductance, it is found to increase because of the fast moving OH minus ions, because we are adding sodium hydroxide in intervals of 0.5 ml. So, addition of sodium hydroxide will result in the formation of OH minus ions. So, after the neutralization point, increase in conductance, it is due to the presence of OH minus ions, highly mobile OH minus ions. So, this is the nature of the graph obtained when a weak acid is titrated against a strong base, and the point of intersection between these two lines will give you the volume of NaOH that is required to neutralize the weak acid, that is acetic acid. Now next is mixture of strong acid and weak acid versus strong base. Here mixture of strong acid and weak acid will be provided to you. Here we have taken HCl and acetic acid. HCl, it is a strong acid, and acetic acid is the weak acid. So mixture of these two acids has been provided to you, and this will be taken in the beaker. To this, conductivity cell will be immersed, and NaOH, it will be taken in the burette. Now initially you will note down the conductance. Initially the conductance, it will be high because of the presence of HCl. H plus ions will be present of the strong acid, and hence the conductance will be high. But when you add NaOH, what happens? The H plus ions, it will be replaced by slow moving Na plus ions forming NaCl. As a result, the conductance it is found to decrease. This continues until all the H plus ions of HCl has been replaced by sodium ions. So you will be getting this line. Now, after all the H plus ions of strong acid has been replaced by sodium ions, again the conductance it is found to increase slightly because of the presence of weak acid, that is acetic acid. Here the H plus ions of the acetic acid it will be replaced by sodium ions of NaOH and forms sodium acetate. So sodium acetate is completely ionized and hence there will be a slight increase in the conductance, and this continues until all the H plus ions of acetic acid has been replaced by sodium to form sodium acetate. Now after that the conductance it is found to increase because of the presence of fast moving OH minus ions, as we are adding sodium hydroxide in volumes of 0.5 ml. Again the conductance it increases due to the presence of fast moving OH minus ions. Now extrapolating the lines, you will get two intersection points. So first intersection point, if you extrapolate the line to the x-axis, you will get the volume, that is V1 ml. It corresponds to the volume of NaOH that is required for the neutralization of HCl by Na+. So this is the line for conductance of HCl, and hence this. Now V2 it indicates the volume that is required for volume of NaOH that is required for neutralizing the weak acid, that is acetic acid present in the mixture. So acetic acid, its conductance it starts from here. So from here to here. That means V2 minus mixture. So using this, you are able to determine the amount of HCl present per liter of the solution as well as amount of acetic acid present per liter of the solution. Now, this is the laboratory experiment for determining the amount of HCl and acetic acid using sodium hydroxide by conductometry. So this is the conductivity cell, 2 platinum electrodes kept at 1 centimeter apart and having an area of 1 centimeter square. It is kept in the solution to be analyzed. In the burette, sodium hydroxide is taken. And the beaker, it is provided with a 25 ml of a mixture of HCl and acetic acid. Now, sodium hydroxide, it will be added in intervals of 0.5 ml, and each time after adding, you will stir the solution well and you will note down the reading in the conductometer. You will be getting readings of this kind. That is, initially the reading it will be high, then the reading it decreases, conductance decreases because H plus ions are replaced by Na plus ions. After that again the conductance it increases slightly because this acetic acid, H plus ions present in acetic acid, it will be replaced by sodium ions forming completely ionized sodium acetate. After that there will be a steep rise in the conductance because of the presence of OH minus ions. Now normality of NaOH it will be given to you, that is 1 normal. Volume of HCl you can obtain from the graph. Volume of HCl it is the amount of solution which you have taken. Now volume of NaOH it is obtained from the graph. So using this, normality of HCl can be calculated. When it is multiplied by equivalent weight, you will get the weight of HCl in gram per liter. Similarly, here you can find out the weight of acetic acid in gram per liter after finding out the normality of acetic acid. Normality of acetic acid, it can be calculated using this formula. So normality of NaOH, we know 1 normal. Volume of NaOH we will get from the graph, that is V2 minus V1 divided by volume of acetic acid, that is 25 ml of the solution we have taken. That will give you the normality of acetic acid. That normality into equivalent weight of acetic acid, that is 60, will give you the weight of acetic acid in grams per liter of the solution. So this is how we determine the amount of substance present in a solution by conductometric method. Thank you.